Hello there. My name is Ali Hassouni. I'm a PhD researcher at the VU University Amsterdam and Mobiquity Inc. In this video, I'll be talking about reinforcement learning and personalization in eHealth. eHealth, or digital health, is defined as the use of information and communication technologies for healthcare. In essence, this encompasses everything related to computers, medicine, and mental care. Due to the recent developments around the COVID-19 pandemic, our lives have changed considerably. The last 6 months have brought to light many challenges to our lives. Our healthcare systems has proven to be fragile in the face of such an unexpected event. People with mental health conditions are getting even more isolated due to social distancing. On the other hand, healthcare workers are performing their jobs under huge pressure. The number of people that require face-to-face care is increasing. This puts our healthcare systems to the test and causes many scalability problems. Luckily, there's a clear trend visible in the amount of attention eHealth is getting recently. The World Health Organization launched the World Mental Health Day to highlight the urgent need for more attention and better solutions for mental health. On the other hand, hospitals are increasingly adopting AI solutions for critical care. So, can recent advancements in the field of artificial intelligence and the ever increasing amounts of data available help improve the state of our healthcare systems? State of the art research demonstrates how important AI applications can be in achieving this goal. Personalization and reinforcement learning are playing a very important role in this. Reinforcement learning is a type of machine learning where an agent is taught by experience. The agent can make observations about its environment it is operating in and can subsequently influence this environment by selecting actions that will change the environment. The agent will then receive some feedback in the form of reward or punishment while balancing between exploitation of what worked well and exploring new situations. The agent is ought to learn policies to act optimally in the environment. To achieve the highest impact possible, policies developed using reinforcement learning algorithms need to be tailored towards each person or patient it is interacting with. This is called personalization. We ran experiments where different levels of personalization were applied to real-world situations in a simulation environment for eHealth. On the one hand, we pull all patients together and develop a one-fits-all policy. The advantage here is that the number of available interactions and data points is large enough. On the other hand, we looked into hyper-personalization, where policies are developed for each patient individually. This eventually leads to the best level of personalization, but at the same time comes with the drawback that a very large amount of data is needed. Finally, we segmented the patients into groups based on the similarity of their behavior over time using clustering techniques, and developed policies per cluster. This approach provides a good level of personalization while not requiring huge amounts of data per patient. To validate our methods, we tested our algorithms in a simulation environment and on offline datasets. After fine-tuning our algorithms and obtaining positive results, we took the next step and built our algorithm into a mobile application that supports people with mental health problems. The goal here is to improve adherence to an online course for low mood with personalized motivational feedback messages. The application is used to rate your mood, plan activities, write down thoughts, and be in contact with your therapist. Our contribution to the app was an AI therapist that relies on reinforcement learning to provide personalized messages that should lead to better adherence to the online course. This experiment will soon be part of a clinical trial with patients with mental health problems. Another interesting application is the development of reinforcement learning policies for COVID patients in the intensive care unit. The dataset contains trajectories of ICU stays at different patients at different hospitals in the Netherlands. The policies are, for instance, developed to help doctors regulate ventilation at the ICU. Similarly, personalized policies are developed to optimize hemodynamic treatment for critically ill patients with sepsis in the intensive care unit. Here, the policies help doctors with finding the optimal dosage of fluids and medication to be given to patients. Reinforcement learning and personalization techniques can be applied successfully in many different settings in eHealth, such as e-mental health, but also for critical care. The right type of data is key for developing the right policies. Successfully bringing these applications to the real world require a tight interplay between healthcare practitioners, researchers, and data scientists. These applications could eventually help solve many problems our healthcare systems cope with.